Section 7.2, estimating a population proportion. The next 3 sections, we're going to be using sample data to predict parameters of a population. In particular, we're going to use sample proportions to I know my statistics, I just can't speak. We're going to use sample proportions to estimate population proportions, and we're going to use sample means to estimate population means. That's the 2 biggies. 7.2 is using sample proportions to estimate population proportions. A point estimate is a single value used to approximate a population parameter. Now, remember, this population parameter is some statistic about the population, so we're going to approximate population means and population proportions, and we're wondering what's the best thing to use for that prediction or that approximation. Well, this is telling us the thing you use to estimate a population parameter is called a point estimate. And a sample proportion is the best point estimate or the best thing to use to predict a population proportion. So we're going to use sample proportions to predict population proportion. Notice that lowercase p is the population proportion. Have we seen this symbol before? I can't remember. Okay, this has an amazing name. This is p hat. Honestly, that's what you call it. This is p hat. P hat is the sample proportion. P no hat is the population proportion. And that, when I say proportion, it could be the proportion of the population who are males, or the population of pea pods that are green, or the proportion of times that you roll a die and land on 7. That's all we're talking about, some percent of a whole. In the chapter problem, which we didn't read, so we're just now getting to it, we noted that in a Pew Research poll, 70% of 1,501 randomly selected adults in the U.S. believe in global warming. Now, I would have liked to have known how that question is worded. Were the participants only asked, do you believe in global warming? Or were they asked, do you believe global warming is a crisis? Or do you believe, more should be done about global warming? I'm not sure what the exact question was. I don't really think there's much debate over whether or not global warming is occurring. You can look at data from history to tell that. The question is it a crisis? Well, that's debatable. But 70% of the 1,501 randomly selected folks said, yes, I believe in global warming. So the sample proportion is 0.7, 70% of the 1,501. So that 0.7 is your p hat, your sample proportion. Find the best point estimate of the proportion of all adults in the United States who believe in global warming. Well, what the previous slide was saying is that the sample proportion is the best estimate of the population proportion. So if you tell me the sample proportion is 70% or 0.7, and you say, what's your best guess at the population proportion? I'm going to say, well, if the sample has 70%, then the population probably has 70% as well. That's all the last slide was saying. Sample proportion is the best thing to use to predict population proportion. A confidence interval or interval estimate. I'm just going to use confidence interval. A confidence interval is a range or an interval of values used to estimate the true value of a population parameter. A confidence interval is sometimes abbreviated as CI. You know that problem that we were doing with Sam, the 8 ounces of Coke in a can. Even when I was talking about that problem, I said just because the can is labeled 8.0 ounces doesn't mean that every single can has exactly 8.0 ounces in it. It may have 7.9. It may have 8.1, but it's going to be somewhere in there close to 8 ounces. A confidence interval is a range of values that we can say with a certain amount of confidence contains the actual mean or actual proportion that we're trying to estimate. I might say, I know that not every single can of Coke has exactly 8 ounces in it, but I'm 95% confident that the mean will be somewhere between 7.9 and 8.1. That's a confidence interval. When I say I'm 95% sure that the average amount of soda in any can of soda is somewhere between 7.9 and 8.1, I've just given you a confidence interval. And I think, if I remember what I just said, I gave you the percent confidence, or the percent confident that I was that the actual amount of soda would fall in that range. I said I'm 95% confident that the amount of soda is between 7.9 and 8.1. If I only wanted to be 90% confident, if I didn't care about being 95% confident, I only wanted to be 90% confident, then I could give you a smaller interval. I might say I'm 90% confident that it's between 7.95 and 8.05. The smaller interval you use for your confidence interval, the less certain you can be that the actual value falls in that range. If you want to be very, very confident that the actual value falls in that range, then it better be a very big range. If you want to be 99% certain, then you better give a big range of confidence interval. A confidence level is the probability 1 minus alpha, often expressed as a percent, that the confidence interval actually does contain the population parameter. Now, what does that mean? Population parameter, we're going to talk about population proportion and population mean. So that's the two parameters we're talking about. If I say I want to be 95% confident that the actual proportion lies within this confidence interval, if I say I want to be 95% certain, then the confidence level is 1 minus 0.9, or if the confidence, I want to be 95% confident, then alpha is 0.05, 1 minus whatever percent confidence I want to have. If I want to be 90% confident, then I'm saying alpha is 1 minus 0.9, or 1 minus 0.9 is 10%. So an 85% confidence level, alpha would be 0.15. And that's the probability that the confidence interval actually does contain the population parameter that I'm trying to estimate. The confidence level is also called degree of confidence or confidence coefficient. I'm not going to use multiple words for the same thing because it's confusing. I'm just going to say 95% confidence level or 90% confidence level. Whatever I give you for the confidence level, you subtract that from 1 to find out what alpha is. And we'll talk about why you need alpha in just a minute. We must be careful to interpret confidence intervals correctly. There is a correct interpretation and many different and creative incorrect interpretations for a confidence interval. If I say that I'm estimating that the population proportion is somewhere between 0.677 and 0.6 0.723 for a confidence level of 95%, then what I'm actually saying is I'm 95% confident that this interval contains the true population proportion. I don't know what the true population proportion is, but I'm 95% sure that it falls somewhere between 0.677 and 0.723. If you only tell me I have to be 90% confident, then I can give you a smaller interval. If you tell me I have to be 99% confident, then I'm going to have to give you a bigger interval. This means that if we were to select many different sample sizes of the 1,501 sample size referring to global warming and construct the corresponding confidence intervals, 95% of them would actually contain the value of the population proportion P. If we put all the people in the world in a big bucket and drew out 1,500 of them at a time, 95% of the time, the proportion of that 1,501 that believed in global warming would fall somewhere in this range. I'm about to need to see an example. I don't know about you, but I want a problem to figure out what this means. To construct a confidence interval for estimating a population proportion P, three things have to be true. The sample has to be a simple random sample. The conditions of a binomial distribution are satisfied. Remember the conditions for a binomial distribution? Only two possible outcomes, success and failure. Define them any way you want to, but that's the only two things that can happen. There has to be a fixed number of trials, and the trials have to be independent of each other. In order to construct a confidence interval, you have the additional requirement that there have to be at least 5 successes and 5 failures. If all of those requirements are met, then you can find a confidence interval on the TI 83 and 84 by pressing the stat button, the test button, and then 1 prop z int. Now, if you keep saying 1 prop z int and you don't know what that means, you're likely to forget when you're supposed to use that button on the calculator. So let me tell you what this stands for. Prop is the abbreviation for proportion. This is a 1 proportion z interval. Z referring to number of standard deviations from the norm, and interval because we're looking for a confidence interval. Let's find the problem and figure out how to use that button. We're going to round our confidence intervals for P to 3 significant digits. All right, we'll worry about that in a minute. Here's a problem. A Pew Research poll of 1,501 randomly selected U.S. adults showed that 70% of the respondents believe in global warming. Now, that's the proportion of the sample who believe in global warming. We're trying to estimate the proportion of the population who believe in global warming. But before that, we want to come up with a confidence interval. The number in the sample is 1,501. The proportion of the sample, that's P hat, the proportion of the sample who believe in global warming was 0.7. Now, when you go to 1 prop z int or 1 proportion z interval, the calculator is going to ask you for 3 things. X is the number of successes. Remember, this is a binomial distribution. Only 2 possible outcomes when you ask someone, do you believe in global warming? Either yes, they do, or no, they don't. And in this sample, 70% said yes, we do, and 30% said no, we don't. For this X value, I have to type in the number of successes. I have to say 70% of the 1,501 said yes. So right here, I calculated 70% of the 1,501. That's 1,051. And I probably rounded that to the nearest whole person because that just makes sense. 1,051 is what I type in for the number of successes out of the sample number, 1,501. And then I have to tell the calculator what percent confident I want to be. That always has to be given to us. Some situations require a higher level of confidence than others. At McDonald's, you might not have to be very confident about the temperature at which you're frying your burgers. But at NASA, you have to be very confident about the safe cargo load of a rocket. If I want to be 95% confident in my interval, then I type in for C level, confidence level, 0.95. And then just move the cursor down to calculate, hit enter, and this is what I get. Let's talk about what that means. But I want everybody to have this on their screen before we go on. If you're having any trouble getting this on your screen, Miss Regina, wave at me. Oh, yes. Okay, let me show. Okay, I think I know what it's. Oh, no. You did one prop Z test instead of one prop Z interval. Oh, okay. Scroll all the way down to A. Yes. Make sure you have one prop Z interval, not one prop Z test. Yes. Not getting it? All right. One prop Z interval, that looks good. 1,050.7, 1,501.95. I'm surprised that not rounding the 0.7 would make that big a difference, but let's see. Everything else looks right. Ooh, something's not right then. Go back, press 1. Oh, never mind. No, it was different. I'm surprised that matters, but I think it does. Yeah, I think it'll work now. Yeah. You're going to have to type in. Since X stands for a number of successes, you can't have a half a success or a third of a success. That's why when we multiplied 70% of 1,501, we had to round to the nearest whole success. Because you can't have half a success.
That's all right.
Let me double check. No. You have the same X and N. X, I think, is right, the 1,051. N is supposed to be 1,501. This problem is tricky because it's easy to overlook. Those aren't the same two numbers. All right, does anyone else not yet have this on their screen? Got it? Okay. All right, let's think about what this means. I don't know if trying to say it all aloud together is a good idea or not, but while I say it, you try to think it. I am 95% sure, because I told the calculator I wanted to be 95% sure, that the true proportion of adults who believe in global warming is somewhere between 0.67 and 0.723. We're going to round to 3 significant digits, so 95% sure that the true proportion lies somewhere between 0.677 and 0.723. The population of my sample who believed in global warming was what? Flat out 70%, 0.70. I can't say with 95% certainty that the entire population have that same proportion who believe. I can't say that. But I can say with 95% confidence that the true proportion lies somewhere between 67.7 and 72.3%. Yep, and I think I typed that on the next slide. No, I didn't. You could say just what you said. We are 95% confident that the true proportion who believe in global warming for the population, that's just P, is between 0.677, I guess I should have less than or equal to, 0.677 and 0.723. And that is only meaningful if you know what P is. What's that P? Proportion of the population who what? Who believe in global warming. And this is the U.S. population. I said world a while ago because I didn't remember the problem, but somewhere it just said, oh, U.S. adults. Doesn't include 5-year-olds. These are all adults. Based on these results, can we safely conclude that the majority of adults believe in global warming? Majority indicates what percentage? Anything bigger than 50%. Anything bigger than 50% is a majority. We are 95% confident that the actual percent is somewhere between 67.7 and 72.3. Both of those are way above 50%. So yes, we can safely conclude that the majority of adults believe in global warming. And that's what the next slide says. All right. We really only do 2 things in 7.2. We construct and interpret confidence intervals. I started to put up my second finger, but that's all part of the first thing. For one thing, we construct and interpret confidence intervals. In order for me to construct a confidence interval, you have to give me either the number of successes or the proportion of the sample and the sample size so that I can multiply those together and get the number of successes. And then the sample size and the confidence level, the bigger the confidence interval, the higher the confidence interval, the smaller interval 99% confidence would require a wider spread than just 90% confidence. So the higher the confidence level, the wider my interval is going to have to be. The lower confidence level, the smaller my confidence interval can be. But I'm going to construct a confidence interval, and then I'm going to say what it means. 95% or whatever percent you ask for, confident that the true proportion lies in that range. Just to check that I've typed everything into the calculator correctly, notice that the calculator gave me p hat, the proportion of the sample. That should be what was given to me as the proportion of the sample. It's not exactly 0.7 because we rounded this 1051, but it's darn close to it. And yes, that is the sample size that I started with, so I can make sure that I've typed everything in correctly.